So this is week 3 of our level 1 CAD class. I heard we have a new student today, so welcome. And it seems like you've watched the recording, so hopefully everyone is all up to speed, at least in terms of having Onshape account and being familiar with the basics of.
Have we done anything interesting when I was gone?
If are you the new student?
Yeah.
Yeah, basically up to now, it's been a bit of a slower pace. We're trying to get ourselves familiar with working with the Onshape interface, the basic CAD tools, mostly focusing on Sketch, but we took a look at the big picture and how we get from our sketches, which are the 2D things, to our 3D objects, starting to use some of these tools like the Extrude function.
I watched your video, and then when I did the sketch thing on the top plane thing, and then I tried inside it, I tried to draw like a line. It would expand the sketch box, and then it would make the XYZ box smaller. I don't know why.
I'm not quite sure what you mean. Could you explain?
So like again? Basically inside the sketch, I would like draw a line. When I draw that line, the sketch expands bigger. So I basically can't draw it outside. If I draw outside, then it'll just expand the sketch outline to where I drew it.
So what, I'm not quite sure what you mean when you say like the sketch expands. So is it different from what you see here when I just am able to draw lines like this?
I can't draw it. Oh, wait, yours expanded. Okay, yeah, that's basically what happened.
Well, if what's happening with you is what's happening with me, then it's completely fine. If it's not, let me know. But
because in the video, it wasn't happening.
All right. Let's work with it for now. If you have any problems, let me know. But if you see what I'm showing you, then it is all okay. So when we left off, we introduced the idea of these sketch relations. And as you recall, depending on your monitor size, they might all be laid out right next to each other one by one, or you might have a drop-down menu like me. But the constraints, the relations, are a set of tools, and we kind of group them together because they have a similar purpose, and that is to define the rules by which your sketch entities can exist. I see also in the chat, someone asked me to talk slower, so thanks for the reminder. As always, whenever I go too fast or something like that, just let me know, because from here it's hard to know what I'm doing or have a good sense. Anyway, our motivation was to understand what Onshape is really doing when we use the rectangle tool to create a shape, because we saw that this rectangle is not exactly the same as something that we create using 4 lines. And what we started to learn is that the difference is these relations, which are also these icons which show up when you hover over a sketch entity which has a relation. So the challenge that I pose to you, and maybe some of you have done it, is to try to draw a tilted square or rectangle, like a rhombus shape, and make it so that even when you drag a point around, it maintains its overall shape without being able to deform into some kind of other quadrilateral. So I'll quickly show you my way of doing it, and you can follow along, get some practice applying these relations so that you get some more time just clicking on the buttons, getting a feel for it. So like you might guess, I will be using the line tool. And for one thing, I'll start off, maybe you haven't done this before, but I'll start off by starting the first line on the origin. Remember that when you start out a new document, there's nothing inside except the origin and 3 planes. So when I say the origin, I just mean this point that's there by default from the very beginning. It's kind of the center of the space that you're working in. And so just like I've done before, I will use the line tool to create the outline of the shape that I want, which is that tilted rectangle. And now, this is what I meant when I say that this isn't really a tilted rectangle, because I'm able to drag the points around, and you can see I can turn it into something weird that's not really what I want. And so when I'm designing a part, that's really bad, because I have some kind of intent. I have some goal for my design, and I need to make it pretty concrete so that it can't just be changed by a mistake by dragging these points around. And so this is where our knowledge or maybe intuition of geometry comes in, where we need to know some certain rules about how the shape that we want behaves. And we'll do that using our relations. So when it comes to a rectangle, for my purposes, I will make it a rectangle that's just at an angle with respect to the X and Y axis, which you see in the navigation cube. So what do I know about rectangles? For one thing, the opposite sides of a rectangle are parallel with each other. So I'll apply a parallel relation to the opposing pairs of lines. And the way that I do that, you can see that I have my relation tool selected, in this case, the parallel one, which I access with the dropdown. And again, with the tool active, which means highlighted, I then just click 2 entities, and it will apply that constraint, that parallel constraint, to that pair of entities. So now, when I drag it, no matter what I do, I can't create that weird L-shaped shape anymore. No matter how I drag it, it will always be a parallelogram, because I force the opposite pairs of sides to remain parallel. Do you have a question, Leo?
Oh, you answered it.
That's great. So that's the first step. And a parallelogram, as you may recall, isn't exactly a rectangle yet. There's one more constraint that a rectangle has that a general parallelogram does not, and that is that the adjacent sides are at right angles to each other. And so that kind of constraint, the right angle or perpendicular, or you might hear me call it orthogonal, is the perpendicular constraint. And so again, that's in the same drop-down menu. It's the same idea. It's just instead of causing 2 lines to become parallel, it'll force them to become perpendicular. And so I can apply it the same way. I select my tool, and I know that it's selected because it's highlighted. And then I click on the 2 entities that I want to force to have that relationship. So once I do that, you can see now that whenever I try to drag one of the points around, it also stays as a rectangle in addition to just being a parallelogram. You can see sometimes it might not look like a rectangle, but that's just Onshape visually updating it. Like there, it'll snap back into place as it calculates the way to render the rectangle correctly. Do you have a question, Leo?
How did you let it move? How did you let it do? Oh, you just pressed a dot?
Yeah. So whenever you have something blue, and this is kind of the next concept that I'll move on to once we've kind of grounded our fundamentals in relations, is this whole idea of blue versus black things in your sketch. So as you saw, I'm able to move all these things around, and hopefully the idea I've given you is that this is kind of not the intended behavior. This is bad, because when I'm designing things, I don't want things to just be able to freely move, because that means my design isn't finished yet. I could be making something like this. I could be making something like this. And with just the rules that I have placed on this sketch so far, that means that there's not a unique sketch that it could possibly be. And almost always you're going to want it to be such that you've put enough rules onto the drawing so that there's only one possible drawing that could exist here. And so hopefully I can make that clear as I go through the example. But what you'll start to notice is that sometimes the lines and the points that you draw will be black. And I may have said this before, but what the black means is that it's fully defined, it's fully constrained. And that means that there's no other possible way that that line or point could exist other than the way it is right now. So it's good to go, it's set in stone. It won't be changing again. So now I'll introduce kind of how we can go about doing something like that. We'll continue with our example here of this tilted rectangle. So hopefully you've been following along and you have something like this that has a similar behavior. And if not, like, don't worry about it. We'll do this so many times moving forward that it'll become second nature. Just try to follow along with what I'm talking about and showing on the screen. And so the first thing that you're gonna want to think about when you're moving towards fully dimensioning or fully defining a sketch is telling Onshape how big it is. And so right now, everything that we've been working with has kind of been in this vague, undefined size scale where I can like zoom into my view, I can zoom out of my view. I don't really have a sense of how big this rectangle is. I could be trying to do a CAD model of a football field, and this is the area that the football field encompasses. Or I could be trying to model a tiny computer chip that's the size of your fingernail, and we have no idea. So the way that we introduce real life numbers, things like inches or centimeters, into our sketch is through the use of this tool, which should be directly to the left of those relation tools. It looks like this. It's where my cursor is. It's the two lines, and there's like the forward backwards arrow that indicates the distance between those two tick marks. So that's the dimension tool. This is probably one of the ones you'll use the most when you're making sketches. And so it might be handy. You can also just press D on your keyboard, D for dimension, and it'll bring up the tool. Again, the tool is highlighted. It means I have it active. And now we'll start to investigate how this tool works. So you may have guessed at this point, the purpose of the dimension tool is to apply a dimension, which just means a length, like 1 inch, something like that. So I'll show you what it does. Just like the other relations, I apply this tool just by clicking on the thing that I want to put this new rule onto. And I click again. And when it does that, it selects this text box for me. And here I can just type in any number I want. Hopefully by default, you selected like inches or imperial units. It's also fine if you have it in like centimeters or whatever. Since in this class, we're not too concerned about designing things to actually fit into a real life system, but I'll be doing everything in inches here. So let's say that I want to call this rectangle 1 inch long. So I do that by typing in the number 1. And now there's an actual connection between the size of my little computer model rectangle that I drew and an object in real life. So if I, for example, wanted to 3D print an object that I maybe extruded this rectangle and made like a little flat card, if I 3D printed that, then we would expect that the result would be a physical object that is 1 inch long this way. And we know that because of this dimension that we just created. So dimension, it's a lot like a relation. It's just that instead of these geometric relationships like parallel or perpendicular or coincident that we talked about, it's just a number. It forces a number onto your parameter, right? Your entity. So that's the first one. I'll show that again and do the other one. So again, I select my dimension tool and it's active. And again, I click on what I want to dimension. I click again to kind of confirm that that is what I want to dimension. And once I do that, it brings up the text box and I can type in a number that I want. So let's say this time I want it to be 1/2 inch. When you work, especially in imperial units, you'll often use like fractions. So if you're familiar with like typical standard bolts or hardware, you'll have seen all kinds of fractions like 1/2 or 3/4 or 1/8 of an inch. And so a lot of the times you don't know the decimal right off the top of your head. You can actually just type in a fraction into this text box and Onshape will do the math for you. Maybe I don't know what 1/2 is in decimal. I just type 1/2 and oh, it tells me that's 0.5. One quick thing, what if you type in the number wrong? Don't worry. The way you change the number that you assigned to these sketch entities is you can simply put your mouse over the dimension, double click it, and then it'll bring up the text field that's editable again. And then you can type in a new number. Maybe actually the design was not to be 0.5 inches tall, it was to be 0.75 inches tall. And then I can just change the number like that. So now let's take a moment to look at what happens when I try to drag these blue points around. And you can see now, no matter, even if I try to expand or shrink the rectangle, it is forced to stay at its dimension, which is 1 inch by 3/4 inch. And nothing I can do can really change that again. So at this point, it seems like we're pretty far along. There's not really much I can do to this rectangle anymore.
How do you delete? How do you delete the things that the diagram thing, dimension thing? Sorry.
The dimensions. So dimensions, it's very similar to any other sketch entity. In fact, almost every entity you can delete first by selecting it to bring it into focus. You can left click on it. So I know that I'm selecting this dimension here because it's highlighted in orange. And then I can just hit delete on my keyboard, which will get rid of it. The other way to delete sketch entities, which we've talked about before, is if you have one, again, I just recreated it, you can right click on it and hit delete sketch entity. That's the bottommost thing on there. And that does the exact same thing.
Thank you.
You have a question, Jeffrey?
Yeah. So when if I have like one of the sides of my rectangle and I click it once, nothing happens, and then I click it again, you left click it twice, right?
Okay.
And is the text box supposed to like be like next to your mouse, next to your cursor? Like that.
Do you mean the location of it, or?
Yeah, I don't see it yet.
So are you editing a dimension that you've already created, or are you trying to create a new dimension?
One that I've already created.
Right, so to edit it, you can double click it. And this brings up this like editable text field, right? Where you can type in your number. You type in a number and then you have to hit enter for it to accept the new value. And then it'll be back to you just being in the workspace.
Oh, I see it now, okay.
As long as this text field is showing, it might limit what you're able to do, but
yeah,
also,
I think like you have to click it and then select it twice and then pull up the dimension tool.
Okay, I'm not 100% sure, but if it causes a problem, let me know. If not, yeah, you do have to double click the dimensions to edit them. Clicking them once just selects it because you might be trying to do something that's not editing the value itself.
Thanks.
All right, so last thing, we're almost there. And I've made all this big deal about turning the sketch black, but nothing is black so far. And that's because there's one last degree of freedom, so to speak, that is remaining, and that is that this rectangle can rotate about this corner. So hopefully you also created the rectangle with one point on the corner. If not,
and
then—
how can your rectangle, like mine can also like just go like in a weird shape. How do I change that again? I forgot. Okay, it can go into like this weird shape.
So if the shape itself is changing, if it's not constrained to be forced into a rectangle, then what it probably means is that you're missing some kind of relation. So if you've studied a bit of geometry, maybe not, if that's okay, you know that there's a minimum number of rules that are needed to force a shape to be a rectangle, for example. And it doesn't always need to be the same set of rules. There are a lot of different set of rules that you can impose on a quadrilateral to make it be a rectangle. For example, you can say that all 4 of these adjacent pairs of lines have to be perpendicular to each other, and then the opposite ones have to be equal. And that's just as valid as what I did, which is saying that opposite lines have to be parallel and adjacent ones have to be perpendicular. But make sure, go through and see which of the relations that you're missing. If the shape is deforming, that really suggests that maybe you forgot one of the relations. And for example, if I delete one, now I'm able to deform it into weird shapes again, you see? And so the simplest set of relations that you can do is just, in my opinion at least, is to make the opposite ones parallel using the parallel relation, and make one set of adjacent ones perpendicular using the perpendicular relation, and that is a fully defined rectangle. Another thing is that you can technically over-constrain your sketch by adding more relations than the bare minimum needed to fully constrain it. So for example, I could say that every single pair of corners has to be perpendicular and the opposite ones must be parallel, and also the opposite ones must be equal. And that's actually more information than I need, but Onshape will still allow it as long as none of them provide contradictory information. What you might have run into also, if everything turns red, that means that you've given Onshape information that contradicts other information that you gave it. For example, if I use dimensions to say that the opposite lengths of this rectangle are like 1.5 and 2 inches, and then I put an equal constraint onto them, then that would over-constrain it because 2 things cannot be different values and also equal.
Okay, I get it.
Do you have a question, Leah?
I don't when I do press the dot, I can only make it up and sideways. I cannot do anything else.
Okay. Just based on your description, it's a bit hard for me to say exactly what's going on there. But
like when I press the dot on like one of the squares, when I press something like the dot on the square and I try to make it bigger, I can only do it up and down and sideways, I think, yeah.
All right, so that's probably a more specific problem caused by maybe a missing constraint or dimension or something like that. So for now, don't worry too much about it. The main goal here is for me to go through an example of how we fully define and dimension a sketch. And then when we do another example later, you'll have another chance to start from the ground up. So I'd say just follow along and make sure you're understanding what's happening. I'll go through a few more concepts and then I'll fully define this sketch and then we will be good to go. So yeah, the last thing, as you might guess, is telling Onshape kind of what angle this rectangle is supposed to be at. So let's say I changed my mind about this whole tilted rectangle thing. Maybe after spending some time designing this part, I decided the rectangle doesn't need to be at an angle. So maybe I just want it to sit flat. Well, we learned one constraint that can help us do that. That is our horizontal relation. So just like any of the other ones that you've done so far, you can select the relation tool, the horizontal tool, and apply it to one of your features. And now, finally, you can see that my entire sketch has turned black. And what does that mean? I try to grab the points like I did before and drag them around. Nothing can move. I can't change anything. And what this means is that finally, I've fully dimensioned the sketch. given the rules that I've placed upon this drawing, given this set of relations, the parallel, the perpendicular, this horizontal, and the two dimensions, all of those combined make it so that there's no other possible configuration that this sketch could exist in. And that means I'm done. Like if this is my job, someone asked me to design a rectangle and I give this to them, then there's no ambiguity. There's no confusion because this is the only rectangle that can exist in this sketch, right? And so let's say I'm done here. Again, as we talked about, when you're done with the sketch, you can just hit the green check mark box and that takes you out. And what you'll notice now that's different. Before the sketch was fully defined, there was a minus sign next to it. So I'll show that again just by deleting the horizontal relation that I just created. And the way you can delete a relation, you can just hover over the sketch entity like I just did. And when these icons come up, you can click on the icon and hit delete. So really every sketch entity, even a relation, is the same. You delete it by first selecting it and hitting delete on your keyboard, or you can right click and hit delete sketch entities. But anyway, now you can notice that everything is blue again because I got rid of that constraint. If you forgot from before, it turns out that I spoke too soon. Onshape does not display the under constrained icon as a minus sign. I may have confused that with a different CAD software, but even if it doesn't do that, the way that you can tell is just by opening up the sketch and seeing if there's anything blue inside. So
wait,
right now
how do you make all of those? How do you make them all black again? Because I'm trying to make them all black, but it's not really working.
Yeah. So as I said, all black just signifies that there's no more degrees of freedom left. There's no more things that could be different and still obey the rules. So the way that I did it in that previous example, I just forced one of these lines to be horizontal. And you can imagine right now, the only degree of freedom is this rotation. So if I make one of these lines horizontal, then it loses that degree of freedom. The only degree of freedom it had left is gone because I made this line horizontal. And so the way I did that, maybe you forgot about this, but one of the relations that we learned how to use is the horizontal. And as you might guess, it turns things horizontal. There's also the vertical, equal. I'm not sure if I showed this, but you can guess what it does. Those are the important ones. We will use some of the other ones later, but I'll explain them when I use them. So let's take a step back for 1 second. There's one last thing I want to show you. And to show you that, I'm going to undo that. So you can hit like Control Z or undo, or you can just delete the horizontal relation like I showed you before, and that'll put you back in this state. Let's say I do actually want my rectangle to be at an angle. What I'm going to demonstrate is kind of the power of this dimension tool. And that is the ability for it to dimension not only lengths, but different types of dimensions that are not just lengths. So you might guess where I'm going with this. You can also use the very same dimension tool to do an angle. And the way that I'll do that, if you have any two lines, I believe they have to be not parallel, and you select the dimension tool, you select one line, and you select another line. It allows you to create a angle type of dimension. And you know that it's an angle type because the number that it tries to suggest has the degree symbol, meaning it's in degrees, like an angle. One thing that you might run into, the dimension tool is what we kind of think of as a smart dimension, where it tries to guess what kind of dimension. It tries to guess if you want a length or an angle or a radius or whatever. So sometimes it might not completely guess it right, and it might try to make a length dimension when you want an angle dimension. In general, the way to kind of adjust it is to position your mouse in the right position. So it takes a bit of practice, but when we get to point where that becomes like an ambiguous situation, I'll spend some time on that. But for now, using the dimension tool, you should just be able to select, in this case, the x-axis. So you can see I can use things that aren't even part of my sketch that I didn't explicitly create. Like I didn't draw a line that is the horizontal axis, but I can actually just select by default what is the front plane, I believe. And then select this thing that I want to dimension the angle of. And with that, I can type in a number, say 15 degrees, just some random number. And just like when I made it horizontal, making it 15 degrees from the x-axis, that is also sufficient to turn everything black, because again, I removed that last degree of freedom that it had to rotate about the origin.
Wait, how do you make it on the angle again? I forgot.
Yep. So again, the important idea here is the idea that the dimension tool can do more than just length. And so the way you do that, you select the tool, you select the thing that you're trying to dimension, and you select the other kind of reference that completes the dimension. In this case, that's our x-axis here. So if you carefully put your cursor above this like horizontal, like faint line, that is your x-axis. So you can click that actually, and then it'll turn it into an angle type of dimension. And you can type in a number. Same as the length dimension.
Thank you.
And so at this point, what I kind of want you to have in your head right now is first the idea of creating sketches. All our 3D parts come first from a 2D sketch. And then in general, you should have some kind of idea of how we move towards the goal of having a fully constrained, a fully defined, a fully black sketch. And the way that you can approach that using a combination of these relations and dimensions. So if you have any questions, I'll pause for a moment here to take them, and then we'll kind of go towards an example. Maybe a bit more of an involved example than what we were doing before. We'll use a few new tools and such. So if there are any questions, feel free to type in chat as well if you don't want to talk. But if we are all okay, I will present to you my first challenge. And so in machine components, you often have something that's called a gasket, which is usually referring to a sealing interface between two components. So for example, like within an engine, you have different components or different enclosed volumes inside that need to hold oil, for example. And you can imagine it's really hard to make something without a technique like 3D printing, where you just have a cavity inside, because it's really hard to manufacture. So usually the way it's done is you have like two halves of it that you join together, and the way that you seal it is using something like a gasket. So that's not really that important, but what is important is this shape. I want you to attempt to draw and fully dimension a shape that looks like this using the tools that you have acquired thus far. And I'll give you a few minutes just to attempt it by yourself, and then I'll walk you through it. And then after that, we'll kind of wrap up our introduction to sketches, and we will start to move on into using some more of our 3D tools, and hopefully starting to move into our first more complex type of project, which is going to be this Sprocket Handle machine. So that's where we're going. But for now, take a stab at creating a shape like this. I do want you to dimension it, but don't worry about the actual numbers. You can just use like 1 inch or whatever for any dimension you want. But the goal is to make this completely black and to have this general shape. So take a minute. So I know I haven't given you much time, but maybe you've had some time to at least think about it. And so at this point, I'm going to ask you a couple questions, which as we move on into more and more complex things like the sprocket machine or the ellipse trammel, the way that we approach this kind of problem where we're given a intended kind of geometry and our goal is to replicate that. The question that I'll always start off by asking you is, what shapes do you see? Even if a shape looks kind of complicated like this one, where it's not just one geometric standard shape, the easiest way to approach a problem like this is to first think about the tools that you have at your disposal, which are things like the line tool, the rectangle tool, or like the circle tool, which I'll explain in greater detail. But right, my point is that when you first are presented with something like this, I want you to think about what shapes do you see? What are the tools that we might use to create this in a sketch? So that is a question I'm asking, so please feel free to respond. The question is, what shapes do you see? And maybe what sketch tools might you use? And don't read too much into it. Simple question. Do you want to hear an answer? You can type in the chat as well.
Are you just supposed to use like lines and rectangles to make it?
Not just lines and rectangles. I know I haven't gone through it, but we also have a few other tools that I'll explain. But
how to use the circle?
Right, great. So looking at this kind of from a distance, I also see some circles. And so the way we're going to approach this is by using the circle tool, which I'll introduce. But
I had a little problem with like it's like a line shape, and I don't know how to make it like the circle like extend at a point but go back in to the center.
Yeah, good observation. So I really like that we see circles in here, because what we're going to be really good at is creating lines and rectangles and circles. But of course, not everything in real life is going to be a circle, because that would be too easy, right? So in order to create these like slightly more complicated shapes than the ones that we are really good at making, we need to kind of get a little bit clever. So
I try to combine like the circle with other shapes to make like the line part.
Yeah, so that's kind of where we'll be going. So if you're working on it on your own, like independently, maybe you're like maybe it's all a bit easy and you're like rearing to go ahead, then continue working on your own like gasket sketch. I'm going to go through a more guided example where I go step by step, and we'll hopefully by the end of it have created this sketch of a gasket.
I found a good one that I can use. It's like half a circle, and I can use it to create like I can use it to create like part of a circle, so I can add it on the side of the circle again.
Yeah, so what you've probably found is like the arc tool. I'll go over that as well. But kind of like from the first principles, I'll start going through a bit of a demonstration. Do you have a question, Leo?
No, is the one next to the tool, the half circle tool, the circle next to it? Yeah, that one.
Yes. So allow me to demonstrate how this all works. So let's see. Yes, as you have noticed, there is a circle tool. And so when we think about shapes, we think about lines, we think about rectangles, and of course we think about circles. And so let's give it a try. By default, it should be set on the first option, which is a center point circle. The icon should look something like this, where you have a dot, circle, and there's a dot on the outer circle. So make sure it's that one. The other ones behave a little bit differently, but it's more or less the same thing. But the one we want is center point circle. So make sure that's highlighted, and we'll take a look. I click once, it creates a dot. And then as I move my mouse around, it starts to create a circle that follows my mouse. And so what's happening is that the first click and the second click kind of define a radius vector, maybe, of my circle, where the first point is the center, the second point is the outside, the end of the radius. And of course, that fully defines a circle from our geometry knowledge, right? So I'll undo that though. And what I want to do is make sure the center of the circle is on the origin. So again, I activate my circle tool. And first I click on the origin instead of just some random place in space. And the reason I do this is because, as you saw, when I want to fully define something, to make everything black, I need to make sure that also it is grounded. It is at a specific location with respect to the origin of the sketch, or the origin of the, the origin of the sketch, instead of just floating off somewhere away from the origin, because if it's just floating, then that's a degree of freedom, right? It's able to translate with respect to the origin. So the reason I'm using the origin as the center is just so I get rid of that one, or that 2 degrees of freedom. All right, so that's the circle tool. And as you know, in terms of a circle, it's defined, maybe if you've taken a bit of like geometry in class, you learned about the concept of a locus, where a circle is just defined as the set of all points that are a certain distance away. And all that means for us is that if you give a center location and a distance, in this case, you might commonly refer to it as a radius or a diameter, then that is enough to fully define a circle. So you can see the moment I attach a number to the circle, it becomes all black, because a center point and a distance is enough to fully define what a circle is. I'll do that one more time just to point out a couple things. Again, this is where the smart part of the smart dimension comes in. It guesses that I want a diameter instead of, say, like an angle or a length or something, although a diameter is a length. I typed in 1 inch, and you can see this little symbol here. It looks like an O with a cross slash through it. And that symbol just means diameter. It's actually a pretty standard symbol. You'll see this in other places as well. For example, in like pipe standards, if you go shopping for pipes and tubing, you'll see the diameter symbol probably, or like hole standards, when you're trying to drill holes for screws, you'll probably see the diameter symbol. So get used to seeing that. This just means the diameter is 1 inch. So
how can the circle be black?
Right, as I was saying, once I create this dimension, it is fully defined, because the starting point for the circle, the center that I indicated it, is the origin of the sketch. And in fact, the origin of my workspace. So given that its location, which is determined by the center, is fixed on the origin, and the diameter, this dimension of the circle, is also defined, then there's only one circle that meets that condition, and that's this one right here, right? Only a 1 inch circle centered on the origin meets the condition of being coincident to the origin and having a dimension of 1 inch.
And I don't think you can like change it after it's like in this shape.
So
change it.
Are you in the situation where it's something like this?
I'm in a situation where it's black.
Oh, that's good. Yeah, that's what we're trying to do. Remember, my goal with any sketch is to make everything black.
All I was trying to do was change like what you were doing, but I typed it into 2 instead of 4, and then it turned black.
Right. So I think there's no problem there, right? As long as your circle is centered here on the origin and you have a dimension, it being black is what it should be. All right. So now from here, this is where we kind of start to do a little bit of thinking, a bit of creativity. My goal here is something that looks like this. And when I asked you guys, someone said that they see circles. So let's try to crystallize that a little bit. What I see here, I see the big circle in the middle, and I see two smaller circles that are off to the side on either side. So let's say I'm going to start off by sketching the holes that are going to be in my gasket first. So the first things I'm going to draw are where the holes are going to be. And so what I observe about the other two holes is that they're both circles. And they're like off to the side outside of the first circle I drew. So what I'm going to do is make that first circle that I drew be this big hole in the middle. And then I'll add two more circles, again, using the circle tool, off and to the side. Now, I intentionally, for the sake of demonstration, put them not on the x-axis, but you can also just use a circle tool and like draw them on the x-axis here. In any case, it'll become equivalent. What I'm talking about is
how do you make the spline tool stop? Like,
are you talking about this one?
Yeah.
Right. So
because when I try to use it and I try to click out of it to stop it, it just creates another point.
Right. The spline tool I'd recommend not using at this point unless you feel very confident about how to dimension things or how to fully constrain things, because as you probably are discovering, the spline tool gets very messy and it becomes very difficult to fully constrain just because each spline has a number of different parameters. Depends on the CAD program, but I think the Onshape ones, let's see. Right, just creating like a 3-point spline that already creates like 5 different parameters that I can edit. So the best use for splines, from what I've experienced, is either when you really don't care about fully constraining your sketch, maybe you're just doing some freeform tracing of a shape. In that case, maybe it's okay to use a spline. And the other one is where you have like, you're trying to fit a curve. So in some applications, for example, like properly done gear teeth, you need to follow like a mathematical curve, like an involute. And in those cases, you might have like an equation-driven curve that you try to fit a spline onto. But for most cases, I would recommend not using a spline just because it gets out of hand very quickly.
Also, I have a question about the recording. When you were creating the CAD, do you go to Cornell?
Yes.
Okay.
Currently studying mechanical engineering. So CAD is something that I spend a fair amount of my time doing. If you are wondering about my credentials to teach this class, although maybe I'm not the greatest expert in it either. So always take what you hear with a grain of salt. Anyway, my goal here is to, what was I saying? Create these other holes. And just for the sake of simplicity, I'll assume like all of these 3 holes are collinear. They follow the same, like their centers lie on a line. And I'll conveniently just choose that line to be this horizontal axis. So if I just happen to maybe naively create my circles wherever, like I did just now, it'll be completely like unconstrained. But the way that I can add a few constraints is by use of my relations. So I'll go ahead and
made it so that like I only can move it left and right because I made it on the line.
Yeah, so that's what I'm about to do. There's a few ways you can do it. I'll show you 2 ways. The first is using our good old horizontal relation, our good friend here at this point. And what I'll do is I'll make the center of this circle horizontal with respect to the center of this circle, which is also the origin. So if I do that, now you can see it's probably the same thing that Henry has right now, where I can only drag it now to be left and right along this line instead of this one, which is more free. It has an extra degree of freedom. I can move it up and down, left and right, follows my mouse, unlike this one, which only goes like that because I made it horizontal. The other one, here we got the same deal. Let's see, horizontal relation, blah, 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 same, I can do that again. Another way I can do it is I can make, use the coincident relation. So I think I showed this once where we had 2 lines that weren't connected to each other. And then I took the endpoints and made them coincident. I can also make the point coincident with the horizontal axis. And so the idea here, it's a subtle difference, but here I'm just telling it that the center of the circle should always like kind of trace along the x-axis like a bead on a wire. This one is saying that the center of this circle should always be horizontal with the center of this circle. So it ends up being the exact same thing. It's just there's always different ways you can apply your constraints in CAD, which is pretty cool. So all right, that's our, yes?
When I first started trying this, when you first gave the challenge, I tried to use the roughest shape that I knew. So then I tried to do like a circle of triangles on both sides over the 2 circles that I made.
Yeah, and like trying things, I'll go on a brief tangent here. When you're learning CAD, I also actually did not learn a whole lot of CAD before I started college. So the best way to like really learn things is to try things for yourself and to spend a lot of time like just playing with the tools, figuring out what you can and can't do. So it's always good, like even if I go through like a very step-by-step example, to just try things on your own and see what you can figure out, even if it doesn't work out. Do you have a question, Leo?
How did you move it in? I tried to on the circle. I don't know how to move it.
So our goal right now is to make it so it can't move. I guess if you're asking in general, like I said before, the way you move anything that's under constrained is just usually by grabbing it by a blue point and just dragging it around.
If from what I experience, you only can grab the center point, because if I try to grab the outside point, it just expands it.
Yes, that is correct. And on that note, I'll introduce another tool, which I've mentioned a few times, but I don't think I've shown it yet. That's the equal tool. Based on an inspection of this picture, I think that these 2 holes, kind of like the ears of the gasket, are equal in size. So what I'll do here is I'll take my equal tool and I'll click on the 2 circles, and that will force them to be equal in size. So it seems like it just shrunk one of them to match the other one, but actually now whenever I drag one of them around, the other one always shrinks or expands to match it because they are constrained to be equal. So all right, that's good. I'm almost there. Now I'll just add a dimension to this circle. Let's say I'll make it a 1/4 inch. And then these circles are still not black, so the last degree of freedom they have is that they can move left and right on this horizontal axis. So easiest way to fix that, I'll just add some more dimensions. So let's say this is going to be a slightly new way to assign a dimension, but it's the same kind of length dimension, the very first kind that I used. So when I defined the length of a rectangle, the way I did that was I picked the dimension tool and then I clicked on the line part. And that told Onshape that I wanted to tell it the length of that line. Instead of that, what I'm going to do now is I'm going to click 2 points. So the center here and the center here. And what Onshape interprets there is I want some kind of dimension between 2 points. And it assumes I want a length. So the dimension I'm creating here is a distance between the 2 points that I selected. Maybe 3/4, arbitrary. And again, same deal. Select the tool, point, point, hit it. And now everything is black again because these circles are fully constrained. Their centers are located by the fact that they have to be 3/4 of an inch to the right of the origin and also lying upon this line. And their size is defined by this dimension. And so that means the circles are fully dimensioned. All right. We're almost out of time, but we've gotten through most of what I wanted to cover, which was, in summary, kind of like an extension of our lesson on relations. Hopefully now you have a solid idea of how you can create a shape that you see, something like this gasket, in a sketch. And don't worry, I'm going to finish up this gasket example, whether today or next week. So I will finish this, but maybe I won't get to it right now. The main thing to take away is this idea of fully constraining something, which is new today, the idea of turning it fully black, right? I use a lot of these terms kind of interchangeably, whether or not that's entirely proper, but fully constrained, fully dimensioned, fully defined, all black, all of those phrases I use to mean the same idea, which is that our sketch is finished. So that's the big takeaway for today. Whenever you make a sketch, you can use these various tools to fully define it. And after you do that, then you'll really be free to start using these 3D tools, because making sure that the profiles, the shapes and regions that you're making sure those are robust, make sure that your entire CAD model is robust and is less likely to break, because like the most fundamental part of it, the very first thing you do, the sketches are all solid. So that's all I really have for you guys today. If you have any questions, I'll put the last minute or so of class to that. Feel free to ask anything about the CAD or previous classes. And if not, I will see you again next week, same time, same day of the week at 6:30.
Bye.